All right, so welcome to DataViz DC, everyone. Um, my, my name is Will Angel. I'm one of the co-organizers here. We're also joined by Amanda, and Ben is unable to make it today. So I'd love to give a big shout out to Excella, and they are one of our sponsors and are very generous to provide us with the webinar hosting for tonight's event. Excella's a cool company. We have a diversity statement and code of conduct. We're all here because we're passionate about data visualization. So you can check out the full diversity statement and code of conduct by going to our website, datavizdc.com. But in short, be excellent to each other and polite in the chat. A couple of upcoming events that should be a lot of fun. I will post links to these on the meetup page after the event. On August 28th, which is tomorrow, there is a data science conference on COVID-19, and that is being organized by Mike Jadu, one of the other meetup hosts here in DC. On September 3rd, we're having our next event, which is an event on building DataViz applications using the Streamlit framework. And then on September 15th, we're having another DataViz DC project night. On that note, if anyone has any announcements, feel free to post them in the chat or and a comment on our meetup page. So if you have jobs, other meetups, hackathons, conferences, or other fun announcements, go ahead and feel free. And Tay, did you have any announcements?
Yeah, so if we're doing announcements, jobs, and everyone loves having those. My company is currently hiring, and I work at Guidehouse. I'll give more of my intro, but I'll post something in the meetup with a link, but it's data science, database engineer, things like that, working with federal clients, and clearances are preferred. So if you're in that space looking for work, holler at me.
Excellent. On that note, last thing before we move on to the awesome presentation this evening, if anyone is interested in being a speaker or has speaker recommendations, or otherwise just wants to get involved with the group or the DataViz community in DC, shoot us an email or reach out to me or Amanda. We're happy, always looking for additional people to help host events like these. On that note, I think I'll turn it over to you.
Whew, okay. Let's get the screen share on.
And one other comment before we jump into it. There is a Q&A feature here in Zoom. If you have any questions during the event, participants can post those there, and then I believe we'll get around to answering them at the end of the event, where we'll have a Q&A session.
Yes. Great. Can you see my screen?
Yes.
Wonderful. All right, let's get started. I'm going to move. There we go. Sorry, I'm getting the screen situated here. Okay, so, greetings everyone. Thank you for joining us this evening. I'm really excited to have the chance to talk to you all. I'm going to start off with a little bit of introduction, context about myself, and then I'll get into my project. And the objective of this is to give you a little bit of the process in addition to the actual content, with the hopes that anyone out there who's looking to build their portfolio, whether from a data viz perspective or a general data science, that some of my experiences might be helpful on your journey. And as well, post your questions in the Q&A. I will have some questions. I want this to be interactive, so I'll post some questions. You can answer those in the chat feature, and we'll, which you're already using, but you want to keep your questions in the Q&A box. So with that, my name is Nate Johnson. If you Googled me, these are some things that you would learn. I went to UMBC as a Meyerhoff Scholar, majoring in mechanical engineering. I minored in modern language and linguistics with a focus on Spanish. From there, I leapt to Carnegie Mellon, where on paper, I continued my mechanical engineering studies, but realistically, I was doing more material science focused work. And I was working on my PhD. So far, I've got my master's there and still pressing forward on the doctoral front. I took a break to come back to the DMV. So this is my home, but I came back a few years ago to work at Institute for Defense Analysis in the federal space, just to get some new experience in a different environment. And that's parlayed to my current post as a senior consultant at Guidehouse, where most of my work is centric to data science. As I mentioned, we are hiring, so if you are looking, by all means, feel free to reach out to me. I'll put my contact info on a later slide at the end. Now, I wanted to keep this interesting, and so these are some things about me that you wouldn't find from your first Google search. And that's some of my hobbies. I enjoy crocheting, triathlons, and I use enjoy loosely in that context, and landscape photography. And while these things may seem like disparate hobbies, there really is this central theme, which is that I'm a challenge junkie. I remember in college, I had friends who crocheted, and I was just like, man, the motor skills to turn a ball of nothing into something so beautiful and intricate, like I could never do that. So then a few years later, I challenged myself to, get over that mindset. And now you're looking at one of my recent creations, thanks to COVID quarantining. I've had a lot more time to play with my yarn, no commuting. And that's the same with triathlon and photography, things I didn't think that I was really able to do, but challenged myself to try anyway. And that actually parlays nicely into my career transition to data science, because as I mentioned, my background is engineering, language acquisition. I really enjoy learning languages. And data science, like that was something I remember in high school, I had sold myself on this narrative that computer science, programming, like talking to computers was way beyond me, my comprehension, like I would never be able to do that. And sadly, I bought into that narrative for many years, like through college and even grad school. And it wasn't until I started working that I really got exposed to it, let my guard down, and kind of opened my mind to the idea of looking into that as something that I could tackle. And in part, it's because my colleagues and peers were in that space. And when I saw what they were creating, I was blown away at how much you could do with tools. And because I have a passion for communication and educating, I felt like this was something that was at the intersection of challenge junkiness and things that I like to do. So for a few years, I tried to teach myself Python and libraries and techniques, and really to no avail, because I wasn't getting really far. So it was kind of serendipitous. Like last year, I learned about Flatiron's Data Science Fellowship program, and it was just the right amount of structure and community that I needed to kind of get myself over that hump of trying to learn on my own. And that was a 15-week immersive experience. Niagara Falls for 4 months. It was just a lot. And there they chose to use Python as the foundational language that we would kind of amass our skills. There was an emphasis on statistics and machine learning, all things that like I either avoided, like the plague, or in this case, COVID, or really just didn't have a good grasp on. And in that time, we had to culminate all of our new knowledge and skills with a 2.5-week capstone project. And while we only had, the objective was to collect data, analyze it, visualize it, and then share. And while we had 2.5 weeks to work on that, we really spent more time on the data collection side of things. And I feel like for me, I didn't have a firm fix on what it was that I really wanted to do. I just had a general idea of what space I wanted to be in. And I knew that I wanted to do something with a mapping element. I knew that I cared about doing things related to social good. And so I kind of went on a really deep exploration of the internet to look for data sets. And I wanted to, from a process perspective, I wanted to just share some of those resources with you all, so that if you're in the market for data sets because you have a specific question, or you're just looking to bolster your portfolio, need to have these recommendations. This is just a snapshot of some of the things that I came across that have really been treasure troves for me. And I'll highlight just a couple of them. One is Data is Plural. And if you haven't heard of that, I highly recommend it's an archive of data sets maintained in a Google Sheet. And I just bookmark it and kind of go in there and just like search based on keywords that I might be interested in. The other one that I'll highlight is NBER, the National Bureau for Economics Research. A lot of economic journals publish their research and data for people to be able to replicate it. So that's also a really cool challenge, is to take data from a larger study and try to recreate their results. One, to just strengthen our science community, but then two, to also give yourself a challenge. So I'll post these links in the event page, the meetup event page, for those who might be interested. But that really leads into what I did for my project. So hunting through all these things, I found a couple of sources that really intrigued me and lit up my imagination. And one of them was Opportunity Insights, which is a large organization that is devoted to using big data to empower policymakers and civic leaders to create targeted local policy solutions with the aim of reviving the American dream. And I was just really struck by the massive effort that they've put over the last at least 6 to 10 years in collecting this data set. And what it contains, they've taken over 40 million records of children and parents linked by social security number, by W-2s, tax returns, they link parent-child pairs, and they track the information of income between parents and then over the years, and then eventually their children, once those children are of comparable age to their parents when they were first born. And that was done by the Census Bureau, researchers at the Census Bureau at Harvard University and Brown University. And I'll show off some of their work at the end, but I was really inspired by their work. And one of their projects in particular is looking at the geography of mobility. And so I mentioned that when I was looking for a project to do, I really wanted to do something with a mapping element. So naturally, I gravitated to this particular topic and also found it interesting. The other data source that was related to, or in a similar space, was looking at countyhealthrankings.org. And that is an effort sponsored by Robert L. Wood Johnson Foundation. And it uses data collected from the American Community Survey, which started in 2010. And it was combining these two data sources that I kind of teased out what it is that I wanted to explore, and really, chasing or following the lead of Opportunity Insights and investigating whether or not the American dream actually exists in America. That's something that I was like, whoa, that's a big question. And what does the data actually tell us? And we might have ideas about it, but what does the data say? So to make sure we're on the same page, I thought it would be useful to at least define this American dream so that we can know what it is that we're chasing. And the definition that we're working under is that there's this ideal by which equality there's equity in achieving opportunity or attaining opportunity. And it's available to any American, regardless of where they're from, who they're from, when they're from, that, you know, your aspirations, your highest aspirations can be achieved regardless of all those things. And here, you know, with geography, it's saying, regardless of where you're from, you have opportunity available to you equally as anyone else. So in seeking answers to whether or not, you know, this is the case, we're first going to take a look at the relationship that exists between a parent's income and a child's income, because ideally, if, you know, what you're able to achieve as a child is independent of, you know, what you started with, then there should be no real relationship between parent and child income. That's one particular metric. And so here in this plot, we're looking at the average parent income. So each data point here is a county, and it's the average income of the parents, and then comparing that to the average income of the child's generation for that particular location. And so we can see that there is a strong correlation where basically the more your parents make, the more you'll make. And that doesn't seem equitable, because that means if you start, you know, at the bottom, you pretty much stay there. And that's not what we want. So if we're talking about looking at, instead of looking at just income, so for this study, instead of looking at just income, we're going to use another figure or another variable termed absolute upward mobility. But really what that's saying is the ranking. So instead of looking at income, if we look at the rank of a parent amongst all of their peers, where they fall on the economic ladder, and then we compare that to their child's rank compared to the child's peers, what is that relationship? And it turns out that that's also linear. So if you go from county to county, you know, cohort to cohort, there is this linear relationship between parent rank and child rank. So using that as just a more absolute term than actual income, I'm going to use that throughout this particular study in lieu of income itself. So here, another, I guess, restraint on that term. So absolute upward mobility, like I said, is the rank relationship between parents and children, but it's on children who were born to parents in the 25th percentile of the national income distribution. And that's going to be important because a lot of these outcomes, or the results of this study, shows that the impact is greater on children who are from low-income families. So we're going to focus just on those in the 25th percentile. So before I go into what the results actually showed about what the distribution of mobility looks like around the country, I want to query you all and just like write in the chat, like, what do you think, or where do you think are regions or areas that offer the most opportunity for children to attain better outcomes economically than their parents? Let's just go over here to the chat. Cities, East Coast, Northeast, large urban centers. Yeah, okay. Large cities. This is so interesting. Oh, I got one Midwester. Okay. Yeah, so the answers that I'm seeing are cities and urban areas. There's a couple people that say I see Midwest and the Pacific Northwest. So we're going to take a look, because I think some of you may or may not be surprised. Oops, gotta go back to my slides. There we go. Boom. So here we're looking at this term, absolute upward mobility, which is telling us what rank a child attained given they were born in the 25th percentile. And this is looking at that by county. So all of the red areas are where we have hotbeds of opportunity, and the pale yellow areas are where mobility is stifled. And so one common idea is that I saw a lot of East Coast and large cities. We're looking at the whole country right now. Later on, I'll get to show you guys specifically, we'll zoom in and take a look at some of the other ideas you guys had. But this is the trend where actually the Midwest is in fact a very poppin' area for economic mobility. And I'll caveat this to say that this data right here is focused on specifically those born between 1980 and 1983. So this is a very specific or tight cohort that we're looking at right here. But one of the takeaways from the Opportunity Insights project is that location matters more for children growing up in low-income families. So this is people who were born in the 25th percentile and managed to attain this income or this ranking by the time they're their parents' age. We'll explore this a little bit more later, but now I kind of wanted to take this a step further, and I was curious, well, what about where you're from matters? Oops. There we go. Given that we understand that location does matter, what are the attributes of a county that are impacting these outcomes for low-income children? And I wanted to explore the different features and characteristics and their relationship with these mobility outcomes. So I mentioned that the data I was using had different features. The county health rankings, the type of information that organization collects was around rates of child poverty, instances of diabetic screening, violent crime rate, adult obesity, unemployment rates. These are the type of things that they had data for. And I took these features and attached them to, or took them with the county and kind of merged it with Opportunity Insights income data. So this is about the actual split of families. So how much does the top 1%, what share of income does that group have? What is the average income of the parents in that particular county? What is the income at these different ranking levels? So I used the income data coupled with the attributes of the county to kind of toss into my model, which I will just say model for now because we're going to talk about that in a second. Rates of physical inactivity, rates of sexually transmitted diseases, teen pregnancy rate. How do those, what are those things? What are those things? Which of those things are most important when we're talking about outcomes for these kids? So from a process perspective, so to put a pause on the project itself, for those of you who are thinking about your question and trying to tease out, what you're trying to answer, at the same time, you also have to think about what methods you're going to use to answer your question. And then not only the method, but also how do you assess the validity of the results for that method? And so for me, given all the things that I was that we're looking at here, I chose to do a binary classifier, which just means that I'm taking a county and I'm making a judgment. Is this place mobile or not mobile? It can be one of these two things, so binary. And I want my model so I had to define a definition of what it means to be mobile. So I showed, absolute upper mobility as a number between 25 and 64. But to say mobile or not mobile, I decided that if a child could move at least 25 centiles above their parents, then that place was a hotbed for mobility, and there are great outcomes that can be attained living here. So we want to study, well, okay, for the counties that have, you know, all this opportunity for movement, like what are the things, what are the attributes of that county, and how does it compare to places that don't offer that kind of mobility? What are the differences? What can we attribute it to? So that was what I chose to do using, I wanted to use a classifier to teach you a little bit about how we assess, or what are the metrics to say that our classifier is doing its job well. There are two important metrics. Well, there's one idea is to use accuracy, right? So did I guess correctly? So if I have my model, it's training on, you know, what it looks like to be a mobile county and what it looks like to be a not mobile county. You know, did I get things correctly if it hadn't, you know, seen this particular location before? And the thing about accuracy, like that's one way to go, but if you don't have a balanced data set, it may not be the best indicator, because if you have a whole bunch of places that aren't mobile and it just learns that, hey, it's not mobile, or this is what not mobile looks like, then it may always just guess not mobile because that's like the safest answer. And you'll have a high accuracy because there's a lot of not mobile places, but it won't have really great distinguishing power. And so precision and recall help us, are ways that we can tease out the distinguishing power of a model. And just to give you a brief understanding of what precision is, if I look at this square here, these are all the things that I labeled or guessed. So these are the points that I chose to identify as positives. The blue circle here is all the things that are actually positive, and the orange-ish circle or semicircle are the things that are actually negative. So when I look at precision, that's saying of the things that I identified to be positive, how many were actually positive? That's my precision. Recall is saying of the things that are actually positive, so all the things that are actually positive, how much did I get correct? How much of that semicircle did I collect? There are other metrics that we could talk about, but these are the two that I'm going to focus on for this particular project. You could also look at like F1 score and some other things. Oopsie, I keep leaving my presentation. Okay, there we go, sorry. Technical challenges. So looking at precision and recall, one of the things that we can also look at is what's called a ROC curve, or receiver operating curve. And what this looks at is without giving you understanding this is I tried, it's like a 20-minute lesson. I don't want to keep you for 20 minutes to explain this. What I will tell you is that this is a way to look at the distinguishing power of a binary, of a classifier. You can use this for more than just two variables. Here we're doing mobile, not mobile. But for these intents and purposes, what you want is to have a perfect kind of square here. I can use a pen and draw. So ideally, your curve would look like it would hug this corner up here. And what you care about is the percentage, this area under the curve. So 89.7, like that tells us this is how much area is under this curve. So that means that this model has decent distinguishing power, and the accuracy kind of supports that. So 81% of the time it's getting things correct. What's interesting is that for this particular model, so here we're just using a logistic regression model. That was my first attempt. The precision, so that number of the things that are actually, that I guessed are positive, how many actually were? Well, my precision was really low, and I've somewhat erased, there you go. My precision was low, so that was a sign that I needed to think about what my model was doing, because it's telling me that I'm not actually identifying positive cases very well. And if positive cases are, places that are mobile, and I'm trying to understand what makes a place mobile, like what are the features that I need to be able to distinguish those a little bit better. So we're not going to move on from logistic regression because that wasn't yielding great results. So then what I ultimately decided to do was random forest. So to give you a little bit of an idea of what random forest means, we're talking about a decision tree, and we make decisions, every day. Do I run this red light or not? There are consequences for that. But really, if I was given a lot of information and I have to decide like whether or not to grant this loan or not based on the information that's available, I want to be careful or choosy about what features are actually going to give me information pertinent to the outcome that I'm trying to address. And so that's what a single decision tree does. It takes a bunch of information and it kind of tells you, yes or no, should you do this particular thing. That's a really high level description of it, and I could, gladly answer better questions or questions about that later. But a random forest is saying it's taking a decision tree and making a whole forest out of it. So it's taking multiple trees and having each tree kind of built using random samples of the data, and then querying that forest and say, each tree, like, give me a decision, is this county mobile or not, based on its attributes. Each tree makes a decision and it says, it votes, and the forest takes those votes and it makes a declaration. It's a very robust technique or algorithm, and it has really great distinguishing power, and it's really resilient to overfitting and things like that. So here we're looking at a way to assess how well it does. We're going to look at what's called a confusion matrix. And this right here, so for a given county, the true identity of this is either mobile or not mobile. And the predicted label, so for the data that we're training on, the prediction is either that it is not mobile or that it is. So what we found is that for all the things that was predicted not mobile, they actually were not mobile. So that was great. It's training, and it got it right 100% of the time. There were no misclassifications. So that's exciting for some training data, but it's just training data, like it already had the answer. So then we want to take we take a slice of data or of the data set that it hasn't seen, and we say, all right, so here's some new information. You haven't seen this before. Run that same test on it and tell me, if you can, what's mobile and not mobile. And the model says, all right, well, of the things that are actually not mobile, I got a good number of them. And of the things that actually were mobile, I did better, and I did better than logistic regression, but misclassification was pretty low. And so if we look at that same ROC curve, which tells us, the distinguishing power, previously our area under the curve was like 87%, and now we're up to 95. So this random forest is telling us a lot better, or doing a lot better at distinguishing mobile and not mobile counties. And it has, good accuracy, but also that precision is a lot better. And one of why this matter, like with the distinction, is that we have a really imbalanced data set. And I'm going to show you in a couple minutes what the distribution of mobile and not mobile counties were. But we'll see that there are like maybe 10 times as many not mobile locations or counties. So there was just a lot more of those things to train with. And so the cool thing about random forest is that it was able to overcome that class imbalance with some of the parameters that you can adjust when you're fitting this. So what did we find? Of all the things that I tossed in the soup, so I showed you guys that list of information on county attributes and income data. Now that we know that, random forest is good at distinguishing between mobile and not mobile counties based on those particular attributes, I then question it and I say, all right, well, what are the factors or attributes that gave you the most information that helped you distinguish between mobile and not mobile places the best? And the top 3 things that helped it make that distinction were share of income held by the middle class, teen birth rate, and unemployment rate. So all this did was tell us that these features of a county give us the most information or help us just like understand its mobility, but it doesn't tell us, you know, the relationship, like what if it's positive or negative. So then from there, I had to look at the correlation. So this here is probably challenging to look at, but this is a plot done in Seaborn, the pair plot. And it's taking each of the features that we just identified. So teen birth rate, unemployment rate, and share of income held by the middle class. It's taking those 3 things and plotting it against the absolute upward mobility, which is what our target variable is. And here, target, because we made it binary, it's either mobile or not mobile. So all of those are plotted against each other so we can see the relationship between them. So here, if I'm looking at absolute upward mobility as it relates to share of income held by the middle class, I can see that as the share of income held by the middle class increases, mobility increases. So that's interesting. When we look at unemployment, it's saying that as the unemployment rate decreases, our mobility is increasing. And that follows some intuition, right? So the more people that have jobs, the more mobility is available for those children. The teen birth rate, as it relates to absolute upward mobility, is also kind of follows intuition. The higher the teen birth rate, the lower the mobility is, or rather, the lower the teen birth rate, the higher the mobility is. So if you're in areas where there's a high prevalence of teen pregnancy or teen birth, the mobility is lessened in those places. And that also follows some intuition because you're younger and not able to, well, there's just more challenges economically. So given that those are the results, now that we see, in general, the model is telling us that these 3 attributes are highly relevant to mobility outcomes, we can take a look at what that is live. Oops, I practiced this, come on. Boom, oops. Boom, cool. So you have to be patient with technology. So this map, so when you load this map up, I created this with a Python library called Folium, and it's taking this particular view here is looking at how the counties are labeled. So I mentioned that definition of a county being mobile, if it had at least if children could on average move up at least 25 centiles. So places that are blue are the places where you have mobility hotbeds. And as you can see, there are not that many compared to this pale white, which is pretty much everyone else. The pop-ups here kind of let you see the highest of the high. So the green are highest of the high and the red are kind of lowest of the low. So in this area, we're looking at Richmond City. And to remind you, like these are, this is specifically looking at children born between 1980 and 1983. And born to parents who were making on average about $27,000 annually. Let's see, high of the high, we got some places in Kansas where people can get to at least like the 63rd percentile amongst their peers. Let's see, up here in Minnesota. So you got to think about this. If you're like, where should I move since I'm commuting or remote working nowadays? You can live anywhere, so might as well go somewhere where the opportunities are abound. So that's what that view shows us. If we switch layers patiently, this layer lets us see the distribution. So I showed you guys the static version of this when we were doing our guess about where opportunity is. And here now we can actually go to each county. So I zoom out because we have, I don't want to ignore Alaska. There wasn't data for, oopsie. That really zoomed out. So here you can see the whole country, but I can just click on a particular location. And if you know what your county is, like you can come and just scroll over it to see, all right, well, what is the mobility, on average for this county? And so here for Montgomery County in North Carolina, it looks like on average, children are able to get up to the 35th percentile if they were born into the 25th. And the unemployment rate there is about 9%, teen birth rate is 25%, and share of income held by the middle class is about 50%. We can zoom out. Let's look at, let's come up here. So where are we? Oh, so this is interesting. I remember people were saying that the urban areas are places where opportunity would likely be great. And when I look at this map, I can tell where cities are because they're the palest yellow ones. So right here, I can tell this is DC. Yep, District of Columbia. And it's usually surrounded. So it's the suburbs around the cities where opportunities are great. But living in the city itself does not imply that you're actually going to have access to all the jobs that we associate with being in the city. And so up here you have Baltimore, and that's another example where it's pale yellow, but then the suburban areas around it tend to have mobility. I'm from Prince George's County, so I'm like, okay, what are the deets here? If I look at the unemployment rate and these, the years for this data are, like I said, for the county health rankings, they didn't start collecting this till 2010. So one of the challenges that I had was making the assumption that the count, like the metrics for these counties persisted like into the early 2000s and early and late 90s, which is when the income figures were from. So there is a discrepancy here in the timeline, but for the purposes of exploring this, that was one of the assumptions that I made. Another interesting note is that this is aggregated up at the county level, but this data is available down to the census tract level. So if you were interested in exploring this, like by neighborhood, I could see what the outcomes were for people on my street, or, my neighborhood, and kind of get an indication of what that's like. Fairfax County was another interesting here. Yeah, so here's Fairfax, and this is where a number of people I know are situated. So Fairfax is interesting because it's hot red, which means that it's a area where there's high mobility for low-income kids. And what's interesting here is that the top 1% in this county actually hold about, well, for the timeline of this data, they held 16% of the income. And so I found that was interesting. And there are other examples of this in other counties where the income distribution of a particular location isn't the, or at least the income distribution in the top percentiles of a location aren't as strongly correlated to, or aren't a stronger predictor as what the middle class is doing in that area. One of the shortfalls to this is that I wasn't able to include education data. So I feel like if I had tossed that stuff in here, that it would have shifted some of this information. And I did find an interesting data set from Urban Institute and the Department of Education, but you know, time, elusive, all that stuff. So that, this, like I said, was built in Python. And if you're interested, on the GitHub repo that I believe Will posted in the slides, you can see the code to generate this. And I'm happy to take questions. I talked about some of the challenges and things that I want to do in the future. And one of the things that I also like to do is look at the outcomes for people who move between counties. That is accounted for in this data, but I didn't really highlight that as one of the features I picked out. So I'm just gonna, that's my get off the slide stage. I told you I'd post my contact info. I'm happy to take questions with the time that we have left. And I see Will's back.
Yeah, that was awesome. Virtual round of applause. And yeah, we've got a lot of great questions. So how about we jump into the Q&A now? Sound good?
Yeah, let's do it.
Cool. So we had a question from Joel back about the relationship between parent and child income comparisons. And the question there is, in the parent/child income comparisons, how old are the children and how old are the parents? What does that age difference look like?
Yeah, that's a good question. The income, so as I mentioned, the cohort we were focusing on for this particular one are children born 1980 to 83. So their parents can be any age. It's just looking at, they had their child in that time frame, and the average age was like, it was above 26. It was like when they looked at what the parents' income was when that child was a teenager. So the parents were like around 35. I don't want to guess because I didn't look at what the age of the parents were. But that information, I guess you could calculate it out. However, as far as the child's age, when we're looking at income, they did wait until the children were at least 26. They looked at income from when the children were 30. So 2004, I think it was like data from like 2012, 2014 for the child's income. But the parents' income was like a snapshot of from like the late 1990s to early 2000s.
Very cool. And another follow-up question on that from George was, don't many children move from where their parents lived? Moving to a different region would have a big impact on income. And so it would be interesting to hear more about how the data set accounts for that.
So children moving from a different location, yeah, that definitely happens. And this is, they did account for that. Man, I'm drawing a blank. Ooh, hold on. I know what I can do. So let's see. I would encourage you, wait, I can do this, to follow up, boom, Opportunity Atlas, my original data source. So I showed you guys my map. My map was a baby map compared to the cool thing that they built, but they had millions of dollars and lots of people, and that was just me. So that's my excuse. But if you go to opportunityatlas.org, you can actually explore and kind of get more information. So some of those questions you guys are asking, they do address those things here, and you can explore all kinds of things. And the outcome doesn't have to just be upward mobility. You can also look at things like incarceration rates, what else? Job rates, things like that. So.
Oh, very cool. And I think the last question we had on the incomes was that income adjusted for area and cost of living? It's a question from Raj.
So it actually, I was curious about this also because I'm like, cost of living, like that has to matter. And they addressed this in a paper where the information income, it scales with cost of living, and it's a linear relationship. So in short, yes, that was thought about, but no, it didn't matter.
Gotcha. And I think we had a question from around the binary classification when we were talking about that. This was from Ryan, and the question was, do you get to work on projects similar to this with your current job?
I have not yet done this in either of my jobs. Um, yeah, a project I'm working on now is actually like building a search engine, and so doing some natural language processing, which is just like a whole another part of my brain. So no, like this is kind of limited to my passion project.
Gotcha. Very cool. We had another question from Joel around how do you classify upward mobility in places where many people seek opportunities elsewhere, with the example being young people leaving farming communities to go to opportunities in cities where their income will exceed their parents' income back home. So was that, does the data set have enough information to account for sort of people, to sort of control for people moving, if I'm getting that question right?
Yeah, so this particular study is focusing on um, where they grew up and what impact of their location, like of where they lived as a child, had on it. So yeah, moving, like that doesn't, them moving to a different city to attain different outcomes, like that happens. The point is that there is an impact of like where you are being raised at and how that parlays into your ability to achieve and attain income opportunities elsewhere. So it doesn't really matter where you've moved to as an adult, because it's about where you started. And I think there's a really great, as a follow-up resource, there's a whole lecture series that kind of explores this a lot more thoroughly, and it's offered by Harvard. It's free. It's the Big Data for Social Economics, I think that's the name of the class, or Big Data for Social Problems. I'll find the link and share it, but there's at least two really great lectures that dive into the study, and they do address the whole moving as an adult, but really the focus is on what impact of where you were raised has on your outcomes, regardless of where you move to as an adult.
Yeah, that makes a lot of sense. We had two questions that I think you touched on very briefly when looking at the model features, but the two questions were, this was from Carl and Michael. It was, do available support resources like libraries or community outreach and access to those resources correlate to highlighted localities? And second sort of half of that question is, are you able to account for federal funding and what the impact is?
Okay. Wait, so it was.
Yeah, so really it was I think the two questions were basically like, what impact do public resources have on upward mobility? The examples being federal funding and libraries.
I really like those questions, and I don't know the answer, but I'm thinking about what would be the proxy for them. Oh my gosh. So part of my future work, there is a tool that's not open source, but it's looking at geographically weighted regression. And one of the things that I can look at is what proximity to a library. So if I put that as one of my metrics for a given zip code, or like how many libraries are in a given zip code or in a given county, like maybe that's how I would incorporate that, and see, how much that affects, what the predictors or what the strongest predictors are. In terms of account for federal funding, I have considered how to include budget data. The tricky part is that things that are kind of offered at the state and county level are not consistent. Like the format of all that data is different. So that is something I would like to do, but would be a much more massive undertaking from, what I've looked at so far.
Right. Yeah. Get that data cleaning and formatting sounds like it would be quite something.
You give me $1 million though, I'd totally do it. I
Good,
do.
very good, very good answer. We had another question from, I believe, Lolita, about, will any of your mapping help a person select the best place to thrive in if they're young and just finishing college?
Oh, so like if they want to start their family, like looking at this to see. So I think yes and no, because right now what we're looking at is historical data, and it's telling us about it's making claims about things that have already happened. So what you're asking is really a predictive question, based on the information for today's city, like can we predict what the outcomes will be for, the children raised in this environment? And that's something that I really want to do, but I haven't quite gotten my methodology down to do that yet. And I think that there's some more present tense efforts about like around doing that. But that's a great question.
Yeah.
You could try.
Makes sense. And this is a question that we've had in the chat and in the Q&A, and actually a question that I had myself, which is, what is the effect of population density on mobility? Because I know for a lot of data sets, as population increases, the variance in outcomes goes down. Like for a lot of healthcare outcomes, that's very true. Is it the same thing here, or does population density have less of an impact here?
That's a good question. And I think that they accounted for this in the data set. They also accounted for children moving from one one zone to another, and they account for it by assigning them like as a fraction. So they count as a fraction for county A, and then at whatever age they move to county B, the rest of that fractioning goes to county B. And there's also studies that kind of look at specifically at what age does moving, like how does that relate to outcomes, like how much does exposure matter, basically. So population density, they did address that, and I'm failing right now as a megaphone because I don't remember what they did to account for that, but it is in that lecture series that I talked about.
Awesome. And I actually had a question. So for the color choices on your map,
Mm-hmm.
did I read it correctly that for your map, red means more upward mobility?
Oops. Yeah, so I've gotten that question before because it's counter. You're like, oh, red always is like a bad color. I can't get it.
Yeah, I'd love to hear a little bit more about your thought process and your decision there for choosing the coloration for the map.
Yeah, so honestly, when I was working on my color scheme, I wasn't particularly thoughtful at first, but then once I saw it, I was like, okay, red, in this term is like, it's like a heat map, it's a hot spot. So there is, hotbed of opportunity at places where it looks hotter. There's more activity, it's, denser opportunity there. And then the other, thought from someone, or feedback I got from someone else, was that it kind of made them think, it made them think a little bit more, because like usually you would look at this and you would just say, oh, okay, red is bad. But now you're like, whoa, this is challenging my perception. Because one, most people thought, like I said, or as we saw in the chat, a lot of people thought that East Coast was going to, be the predominantly, I guess, mobile area. And really it's Appalachia, like the mines out there, and then Midwest, like I guess it's the oil. I thought about too, like what are the industries and economies based on in these places that really challenge what we think about.
Yeah, very, very cool. Um, and yeah, I think we had another question. It was that the question was that I've heard the American dream in reference to immigrants quite a bit. Did the data consider if a family or people immigrated to the US? Was that a factor that you had access to?
Uh, Me specifically, no, because unfortunately, well, fortunately and unfortunately, I was using an aggregated data set. So they had already done a lot of filtering and processing to kind of get the metrics that I was using and tossing into my model. The original study, they did talk about distinguishing people who migrated to the US versus those who were born here. And really all it did was just how did they did something to account for the absence of data, that would exist, prior to age 5 or whatever age, that child moved here. So they did address that, but I didn't have that specifically in here.
Yep, makes sense. And I think we had another question from the chat that was asking about if there is an upper bound on a child's potential mobility. And the question was especially in reference to counties with high baseline income ranks. So that there, I guess the question is, if you're born in a really wealthy county, does that put an upper limit on how much upward mobility you'll have?
So yes and no. No, it will not impact your absolute upward mobility, because absolute is measuring from 0. So it's looking at your rank compared to your peers. And if your parents were from the 100th percentile and imagine like you were also in the 100th percentile, your AUM is still 100 because that's the rank that you achieved. If you're looking at relative mobility, how you moved relative to your parents, then yes, you wouldn't be able to move very far relative to your parents. Move up. And that's the other thing. This is also upward mobility and not just mobility, period. Because there are also people, right, that don't attain outcomes higher than their parents. So this is specifically trying to study places where people are moving up, because that's what we want to strive for. And as a policymaker, I want to understand, well, what are the attributes that I can focus on in my local community that will help me equalize in terms of achieving opportunity or attaining opportunities. So that's kind of why the focus is on upward mobility and not just mobility in total.
Right.
Answers the question.
I think so. And I think at that point we're pretty close to out of time. So unless you have any closing words, how about we wrap up there?
Boom. Well, I mean, I want to say thank you to, Will, Data Viz Society. I appreciate having the platform to share. And I'm really excited to talk to anyone who has questions about the research itself, the journey. This is something that I'm still kind of working on. This is incomplete work, but you can check out my GitHub and you'll see something a little bit more packaged around this particular project, but there's other stuff that I have also. So yeah, I just thank you all for joining us tonight, and thank you, Will, for being such a great host.
Yeah, thank you for that awesome presentation today. It's a very cool project. Looking forward to seeing more work done on it. Thank you all to everyone who attended. Hope you had a good time, or I'm confident you did. This is an awesome presentation. To stay tuned to further events, keep an eye on our meetup page or visit datavizdc.com. All right. Thank you all and have a great night.